Good morning, students. In the previous classes, you studied what is an acid, what is a base, what is an alkali, its physical properties and chemical properties. Today, we are going to start with salt. What is salt? Salt is a compound which, when dissolved in water, yields a positive ion other than hydrogen ions, H positive ions, and a negative ion other than hydroxyl ions, that is OH negative ions. Now let us take an example of a salt, sodium chloride. When you dissolve it in water, what do you get? Aqueous solution of sodium chloride. It dissociates to give sodium ions which are always positively charged other than H positive ion, and a chloride ion which is negatively charged other than OH negative ions. Is that clear? Now there are 6 different types of salts. Number 1, normal salt. Number 2, acid salt. Number 3, basic salt. Number 4, double salt. Number 5, mixed salt. And number 6, complex salt. However, we are going to study only 3 types of salts in detail: normal salt, acid salt, and basic salt. What is an acid? What is an acid salt? The salts formed by partial replacement of the replaceable hydrogen ion of an acid by a basic radical or ammonium ion. Basic radical here refers to metallic ions. For example, sodium hydrogen sulfate. It contains a replaceable hydrogen atom in its molecule. Similarly, sodium hydrogen sulfite. Sodium hydrogen carbonate, also called sodium bicarbonate. Now, when is an acid salt formed? How an acid salt is formed? An acid salt is formed when you react a base with an acid. It gives salt and water, but you have to take into consideration the quantity of base that you have taken. For instance, if you take insufficient sodium hydroxide and react with sulfuric acid, it gives you an acid salt, sodium hydrogen sulfate and water. Acid salts contain a replaceable hydrogen atom in its molecule. Acid salts exhibits all properties of an acid in solution. That means it shows properties very similar to acids. Now the next one is normal salt. The salts formed by complete replacement of the replaceable hydrogen ion of an acid by a basic radical or ammonium ion. For example, sodium sulfate, sodium sulfite, sodium nitrate, sodium chloride, sodium carbonate, etc. Look at these salts, they do not contain any replaceable hydrogen atom in its molecule. Now, how do I prepare a normal salt? When you take excess of the alkali and react with insufficient acid, okay, then you get a normal salt and water. For instance, excess of sodium hydroxide solution when reacted with dilute sulfuric acid gives you sodium sulfate and water. Normal salt does not contain any replaceable hydrogen ion or atom in its molecule. It does not exhibit properties of an acid in solution. Next, we move on to basic salt. Basic salts are formed by partial replacement of hydroxyl radicals of a diacidic or a triacidic base with an acid radical. What do you mean by diacidic base? For instance, calcium hydroxide CaOH2, magnesium hydroxide MgOH2, or triacidic base, for instance, aluminium hydroxide, ferric hydroxide Fe2OH3. Examples of basic salts: basic copper nitrate, basic copper chloride. You see there is hydroxyl ions there in the compound. Okay, hence they are called basic salts. Methods of preparation of salts. There are a number of ways how you can prepare salts in laboratory, and it's very important from examination point of view. In ICSE, almost every year you'll find some questions are from this part of the chapter. First one is direct combination. Direct combination you have studied in the lower classes, 8 also, 9 also. Okay, when an element A reacts with B, it gives you AB. Now, heated iron, when you react with dry chlorine gas, it gives you ferric chloride. What kind of salt is ferric chloride? Soluble salt. That means it's soluble in water. The next is heated iron. When reacted with boiling sulfur, it gives you ferrous sulfide, which is an insoluble salt. Similarly, heated lead, when reacted with boiling sulfur, will give you lead sulfide, which is also an example of insoluble salt. Now, the second method is simple displacement. You studied in the previous classes also. Zinc, iron, magnesium, etc. These are all active metals. It displaces hydrogen from dilute acids. So zinc, when reacted with dilute hydrochloric acid, gives you zinc chloride and hydrogen gas. So the salt formed is zinc chloride, which is soluble in water. Next, iron, when reacted with dilute sulfuric acid, the salt form is ferrous sulfate and hydrogen gas is given off. Now the third method is precipitation, also called double decomposition. All insoluble salts are produced or prepared by this method of precipitation. Let's take an example. For instance, silver nitrate solution, when reacted with sodium chloride solution, gives you a white precipitate of silver chloride and a clear solution of sodium nitrate. The second one, barium chloride solution, when reacted with dilute sulfuric acid, gives you a white precipitate which is insoluble, and that is barium sulfate and hydrochloric acid. Look at the third example. Lead nitrate solution, when reacted with sodium sulfate solution, gives you lead sulfate, which is a white insoluble precipitate, and a clear solution of sodium nitrate. Similarly, zinc nitrate solution, when reacted with sodium carbonate solution, gives you a white precipitate of zinc carbonate and a clear solution of sodium nitrate. So mostly insoluble salts are produced by this method, and that is precipitation. Now we move on to neutralization. Neutralization you have studied earlier. When a base reacts with an acid, it gives you salt and water. So sodium hydroxide solution, when reacted with dilute hydrochloric acid, will give you the salt sodium chloride and water. It is soluble in water. Similarly, ammonium hydroxide solution, when reacted with dilute hydrochloric acid, will give you ammonium chloride and water. Now there are few insoluble bases also. For instance, copper hydroxide, lead oxide, okay, cupric oxide, ferric hydroxide, these are all insoluble bases. When you react with acid, it gives you salt and water. So copper hydroxide, when reacted with dilute sulfuric acid, will give you copper sulfate and water. Similarly, lead oxide, when reacted with dilute nitric acid, will give you lead nitrate and water. Number 5, by decomposition by acids. Okay, that means you're taking a carbonate salt or a bisulfite. Okay, you are reacting with an acid, it gives you what you call salt, water and a gas. So if it is sodium bicarbonate, it gives you salt, water, and carbon dioxide. If it is bisulfite salts such as sodium bisulfite, potassium bisulfite, when you react with dilute hydrochloric acid, it gives you sodium chloride, water, and sulfur dioxide gas. And the last of all is by action of alkalis on amphoteric metals or oxides. I'm sure you know what is amphoteric metal. For instance, zinc, lead, and aluminium. These are the three amphoteric metals that you have studied. Now, oxides of these amphoteric metals are what? Zinc, what you call, it can be an amphoteric oxide or a hydroxides. Okay, zinc hydroxide, lead hydroxide, or aluminium hydroxide. Now, let us take a look at uh, the equation. Zinc, when reacted with sodium hydroxide solution, will give you sodium zincate and hydrogen gases evolved. The second one is zinc hydroxide solution reacts with potassium hydroxide solution to give you a salt, and that is potassium zincate plus water. With this we come to the end of preparation of salts. Please revise the chapter thoroughly and learn the equations. Thank you.